Hello everyone, it's December 12th, but we are going to do tomorrow's challenge. Alright, it's called consecutive characters. Let's take a look. It's an easy question. Hopefully we can handle it pretty smoothly. Alright, let's see if we've done this before. We have back in still in November last year. Alright, November last year. Let's see. What do we have? Consecutive characters. The power of the string is the maximum length of a non-empty substring that contains only one unique character. Okay? Given a string, we return the power. So we want to find the maximum length of consecutive characters. So that's 2. Okay. Consecutive characters. I'm pretty sure Python has something for it. I think Python has group. Let's try. I think it's in the tools. Let's take a look at it. The tools. I think it has group. And I remember I read it before. It says basically group has a different behavior compared to group by. Oh, we'll take a look. Wait, I'm now looking for. I'm looking for the tools. This one. That's what I'm looking for. I think group by is group the same character. That's what I remember, but I'm not 100% sure. Group by. It's actually group by. Let's take a look at group by. So group by consecutive keys and groups from the table. So if we call group by, if we call K and G lists. Okay, so we basically call group by, and then we return the length of the second one, and then get the largest. Okay, so yeah, let's try this. So I'm gonna say, I think what I'm gonna do it in 2 ways, right? So first way is going to be group by, and the second way will be we do it by hand. Alrighty, let's take a look. So first way is going to be group by. Oops, see daisy, got the wrong thing. Alright, what am I doing? Come on, press the wrong button. Right, so we're gonna say from the tools import group by, right? So we're gonna return the max. So for this G in group by S, and then len G. Okay, let's try this. We have, I'm going to copy this. Alright, we have a LeetCode, which gives us, hold on, we have LeetCode, that's 2. What's the next one? Whatever this is, it's going to give us 5. Right? And the next one is this, going to give us 5. And the next one is this, oh, that's going to give us 11. This will give us 11. And this will give us 1. All right. Test this. Max power. Run it. Oh, has no LAN. Oh, I might have to call list on this. There we go. We do have to call list on it. Otherwise, it's not gonna work. Okay. So let's submit this. Oh, I got it. So I'm pretty sure that was the same solution I had back then. All right. So this is what should I call it? This is the group by solution. We hit a 48. This is 48 milliseconds. 44%. All right, so what else do I have? Well, the other solution will be to try to write this ourselves, right? So basically, we're gonna have two. Now we just need one pointer. So when rest equals 0, and for I in range, we can say 1 to len s, right? I'm gonna say, well, actually, rest is 1, right? Rest and count, both are 1. If si is equal to si minus 1, right? That's consecutive. Then count plus equal to 1. Else, rest equals max, rest and count go back to 1. Now return rest. All right, try this one. Pass as well. So this is a second solution where we do it ourselves. Let's submit this. Wait for the result. Oh, I think we have the same problem as the previous one. I'm pretty sure that's the exact same problem I had. Oh, wow. I did not improve at all in this case. That should be 2. And we why? Oh, I did not return max, rest, and count. I just realized. Right? I just realized. I think we have the exact same solution as a year ago. Even the same pattern. Even the same pattern. It's gonna score 32 as well. I always score 44, but it doesn't matter. I think if we take a look at this and take a look at this, we'll find out that's exactly the same. So this is counting on our own. Right, it's counting on our own. So when I just want to run the 44, 63. All right. All right. Let's see if that's the same. I think it should be the same, even the one that was wrong. Not exactly the same. What is this? A pre? Oh, I was doing this. See, we got it wrong on the exact same test case. And then I realized, I need to check the max. I'm gonna check the max. Okay, so that'll be it. That'll be it for this. All right, I'm gonna do the other one. I already have it open. This is one called a water and a jug problem. You're given 2 jugs with capacity jug 1 capacity and jug 2 capacity liters. And there is an infinite amount of water supply. It sounds familiar, but I've not done this before. No, I've not done this before, but it sounds familiar. 2 water jugs. Okay, infinite amount of water. Determine whether it is possible to measure exactly target capacity using these 2 jugs. Yes, I remember. I even remember that was like an IQ test back when I was in the middle school. I think it was very popular. Middle school is very popular. This type of like brain twisters. Okay, so if target capacity liters water are measurable, it must have target measure contained within one or both buckets by the end. If it's measurable, it has to be inside one or both. Operations allowed. Fill any of the jugs with water. Empty any of the jugs. Pour water from one jug into the other till the other jug is completely full or the first jug itself is empty. Die Hard example. I must be a movie reference, I don't know. I never watched Die Hard. Anyway, so 3 and 5, target capacity is 4. Well, I didn't tell you how it is done. You just return true or false. Wait, how do you do 3 and 5? If 4 is measured, then you must have target liters containing one or both. Wait, hold on. How do you do this? 3 and 5. Well, we have 3. We pull 3. And then we pull inside 5. Okay. So I have 3. We'll pull inside 5. So 5 has 3. Now we fill up 3 again. Now we try to fill up on 5. Then I will have empty out 2 liters. Now we have 2 liters in 3 and 4 and 5. And I dump out 5. Now I have 2. Then I fill up 5 and pull all the way into 3 because I have 2 in it. So I'll fill it once. The remaining 5 is 4. Okay. This is a convoluted process, right? So we have 3 and 5. So I fill up 3. Then we go into 5. Right now we have a measure of 2. And then we fill up 3 again. We pull in. So basically that means we can always get the difference between the 2 jugs, right? So we can get 2 liters on 3. So we get a difference. 5 minus 3 equals 2. And then I can pull all 5 or fill up 5 and we pull in 3 until 3 is full. So I can get, so 5 minus 3 is 2. And then we can always do 3 minus 2 equals 1. So that's how we can measure, not really measure, that's how we can remove, right? That's actually remove. Not really remove. Well, we pull 3 into 5, so 5 contains 3. Then we fill up 3, we pull into 2. Oh, then in 3 we remain as 1. Right, we remain as 1. Alright, so that's so in 3 remain as 1. And then we fill up 5 and pull into 3. And 3 has 1 in it. So now we have 5 minus 1 equals 4. So how does the whole chain of reaction happen? So we have 5 minus 3 equals 2. And then 3 minus 2 equals 1. And then 5 minus 1 equals 4. Right? This is the whole chain reaction. Which is the only way to go forward, because if we're given these 2 jugs, and if the jug itself is not the target capacity, then the only way to try to work towards the target capacity is to take the difference, right? So to take the difference, that will be the only way to get a new measurement, right? So we can take the difference, and once we take the difference will reside in the bigger jug, right? The difference will reside in the bigger jug. Now, then we can go this difference, we can produce the secondary difference in the smaller jug, which is 3 minus 2. And then this smaller difference, then we can make another difference in the big jug. So the first difference is happening in the big jug, second difference in the small jug, and the third difference is the big jug. And that's the only way, right? So we have the difference in the big jug, and then what can we do with this difference is by pulling inside the big jug, right, from the small jug. And actually, in that case, when we saw the difference in the big jug, we try to pull from the small jug into this big jug, and that's actually a modulo, right? Because we can pull many times if the small jug is small, so we can pull many times to obtain a difference in the smaller one. Okay, and then from the big one we can get to the smaller one. Once we get there, right? So we get there, I have 5, and we filled it up. Wait, hold on. That's not right. I'm gonna do this again. So we have 5 minus 3 is 2. That means on the big jug I have 2 left. So I try to fill the smaller jug into the 2. So now the smaller jug has 1 left. Right, smaller jug has 1 left. Actually, oh wait, hold on, this is not done. Smaller jug has 1 left, and the bigger jug has so if we go bigger jug, fill it all the way up, and we pour into the small jug, the small jug is full, and the bigger jug with its full is 5, and the small jug actually have 2 left. So the bigger jug becomes 3. Hold on, we're not done yet. Okay, I think I got confused earlier. Oh, it's from the small jug. I pull 1 into the big jug, and then small jug I fill up, and then pull inside the big jug. Now we get to 4. I see. Hold on. All right, for one thing, if the target capacity is larger than the sum of the 2 jugs, then that's not possible. If it's equal to, that's immediately good. If it's equal to the sum of the 2 jugs, that's good. If it's equal to any one of the jugs, that's good, right? So the only possibility that we need to concern is the target capacity. What if it's smaller than one of? Well, it's still possible if it's smaller than, right? Okay. Yeah, if it's smaller than, it's definitely possible. Okay. If it's smaller than, like if it's very, very small. Well, if it's very small, when the method to begin with is always to obtain a first difference, right? The difference between the 2. That will be the first That would be the only step to start with, because other than that, there's no other way, right? So we always obtain the difference. Basically, we fill up the small and we pull into the big, right? And then we're gonna have the remaining, which is the difference between the big and small, right? If we have this difference, what does that mean? That means we basically have two new jugs. And one jug is whatever the small one, and the other jug is a new one, right? And now the question becomes, can we fill it using these two? Okay. So we start from 5, 3, and after one step, we're going to have jugs 3 and 2. So the question is, can we have 3 and 2 to produce 4? Hold on. 3 and 2. What can 3 and 2 do? I mean, the goal is to produce new volume, right? So after the first round, there's no new volume. There's no new volume. We still have 3 and 5. So we need to produce new volume. So we do the first round, so we have 2 left, and then we can produce new volume as we try to fill up this 2, right? Once we fill up, then we get the new volume, which is the modulo. So we get the 3, we have a modulo, right? That's 1. That is the new volume, right? We get the new volume. Okay, so that's the only one we can do to get a new volume. Now the question is, can we use this new volume? Like for 4, we can use this new volume because 4 happens to equal to 1 plus 3. And we also know if it's going to be possible, we want the 4 to be all inside the jug 2. But it's not necessary. It's just we will have we have 1, right? So we obtain the first. Or is that the only other volume we can have? I feel that's the only other volume we can have. All right, we have this, and then we get the volume of 1. Right? Can we get another volume? And once we get volume 1, but it seems to we can also get volume of 2. Right? We fill up 5, we pull into, so we can get volume of 1 and volume of 2. Right? That's the only 2 volume we can get. And once we get those volume, right, on the 5 side we have, so hold on, with volume of 1, it's on the 3 side, right? It's on the 3 side. And then if we fill up on 5, and then we pull in, then we can get another volume. But that volume is going to be the same. Is that always going to be this? Okay, let's do, oh, hold on. So we get 1, right? And if we have fill up 5, Then we pull into this. Then we get 3 on the 5 side, which is not really useful, right? Which is not really useful. Okay, and it's not really useful. Another one is we fill up 5, we pull into 3, so on the 5 side we have 2, right? And if we have 2, we can pour these 2 into 3, right? So we got 2 in, and then we fill up 5, and then we pour into 3, then we'll have filled 1, then we have 4 left in the 5. Now, that's another way to do it. How do we summarize this? Well, to summarize this, I think these 2 steps are pretty straightforward, right? So one step is small pull into big. We keep pull small into big until we have a modulo inside the small, right? So that's one way to handle it. We pull small into the big and small into the big. Pull small into the big, then we got a remainder, right? And then we can do small minus this remainder. That will be whatever is left in the small. That's one way to handle it. Or we can pull big into the small. Right? If we pull big into the small, then whatever is left in the big, that's another way, right? So after the first step, if the small pull into the big, I get something. Then what? Then what we can do is we can pull big into small or small into big. Yeah, that's the only 2 ways to do so. Small into big or big into small. Now, we have something in the small. So if we fill up small and pull into the big, that would be exactly the same thing as we did previously. So we don't do that. So what we do is we pull into the big and then we put that into small. Because that will create new things. Okay, so we pull into the big and then we pull into the small. So in this case, big is 5, right? Hold on, let me try to think about it again. That's 3, we pull into this, and 3, we pull into the 5. Now we have 1 left, right? And then we're going to go from 5 to pull into 1, and then 5 minus 1 equals 4. Then boom, we will have solved it already. Now the other way is we have big, we pull into small, right? And then big has 2 left. And of course, we don't fill up the big again and then pull, because that would be stupid. So we're gonna pull, fill up 3, and then pull into 5. Oh, that's stupid, because we just filled up 5 to pull into 3. So we have something left. Now I'm filling up 3 to pull into 5, and that will be the same thing, unless. Oh yeah, unless in that case we can say we have 5, so we pull into 3 once, right? And that is the remainder, right? That is the remainder. And the remainder is after we pull however many times, whatever's the remain, in 5. Now that is a remainder. And of course, during the pouring, so every time we pour, we can also check to see if that fits, right? And so we were given a target, and then we can pour into 3, and we can check like whatever is left in the jug 2, in the bigger jug, if it's equal to. It's not equal to, we'll point to 3. All right, and then if it's still not equal to, we'll point to 3 again. And if none of this is equal to, then we pull until we cannot pull again. So the remainder will be 2. All right. Now if we pull 2, if we pull 2 into the small, yeah, we can pull 2 into the small, or we don't pull 2 into the small. No, we pull 2 into the small, right? And then we can fill up 5 and then pull that into the small again, then we get 4. And during any of these times, we don't, it's like we always go one direction, right? Either the big into the small or the small into the big, because if we go big into the small and then suddenly we go small into the big, that will just be the same, right? It won't change anything. So we always go big into the small, right? Big into small, and every time we always fill up. So we can check, no good, and then big into the small, and then big into the small again. Then the small becomes smaller. Well, it's actually only smaller for one round, right? Only one round, because if I fill it up, I cannot go back. Or can I? Or you cannot. So next time will be -3. But that'll be 4 minus 3. Right? That'll be 4 minus 3. And then we pull it in. Now we have 1 into the small. And then we try. Then we'll minus 2. And that'll be 3. And we pull 3 in, and that'll be 0. So from 2 to 1 to 0. And I'm pretty sure we go small to big, that will be the same thing. Okay? So what are we saying? So what we're saying is, given 2 jugs, right? Given 2 jugs, A and B, okay? Suppose A is smaller than B, then we can always, so after the first round, we can always get B mod A, right? B mod A will be the remaining in B, and then we can put, let's just say B equals KA plus R, right? So after this, we'll have R remaining in B, and we can pull this R into A. So the remaining, the capacity in A is A minus R, and then, right, that will be the first time. And then I can fill up B and then pull into, so basically we can obtain B minus A minus R, right? We can obtain B minus A minus R. We can obtain that value. And of course, along the way, right? How do you handle along the way? But hold on, so this is the first value, right? And then basically I have that much. So we can do B minus A minus R. We can do this mod A, right? We do this mod A. So B equals KA plus R. We're going to minus A, right, and a plus R. Then we have K minus A, K minus 1A plus 2R. 2r could be larger than a. But anyway, we can obtain a new value, right? We can obtain a new value that is going to be inside the big jug, right? And then using this new value, we put into the first one, and then we can run this again to check. All right, we can run this again. We filled it up, and then we can minus this. That will be the new value. That's the new value. And then once we get this new value, if it's still not good, keep minus, keep minus, keep minus, and then every single round, I think we'll obtain new value. Okay, let me just do let's say jug 1 and jug 2. Let me do this. So we can go 0 and 5, right? So 0, 0 starts with 0 and 5. So 5 is first value, we can check. And then we can move 3, so we have 3 and 2, right? So all these values are good, 3 and 2, right? And then we're gonna dump 3, so we're gonna have 2 and 0, right? So the same. And then we're gonna fill up 5, right? We're gonna fill up 5, and then we dump inside. So we dump inside. Oh, so now we have 2 and 5, right? We fill up with 2 and 5, so that's 7, right? That's 7. We have 2 and 5, and then 5 we can dump it in. Now we have 3 and 4, right? We have 3 and 4. Now after we have 3 and 4, we can dump 3, and then we're gonna have 3 and 1, right? We have 3 and 1, and we can dump 3 again, put 1 in. Now we're gonna have, we already have 1, right? So we're gonna have 1 and 5. Right, so we're gonna have 1 and 5. And then we can dump 3 in. So we have 3 and 3 and 3. Right? Then I think we go back to the start. 3 and 3. And the last step is going to be 3 and 0. And then we go back to 0 and 5. Right? So that is the whole process. And I do believe that every value will go through this whole process. Therefore, we're just going to go through the entire thing and then check if any of the values can fit the target capacity. All right, let's run another example. Okay, so jug 1 and jug 2, we're going to start with 0, 0. All right, always start with 0, 0. And then I'll look at the second example, 2 and 6. So first one will get 0 and 6. All right, and then we're going to get 2 and 4. All right, so these are the values that we can do, 2 and 4. No good. Do it again. 2 and 2. Okay, so we do it again. 2 and 0. Right, and then that's it. We go 2 and 0. So these are all the possibilities that we can obtain. So this one will only have, we can do 6. We can do 4. We can do 2. 6, 4, and 2. So no 5. Right. Last example, 1 and 2. So we can always do 0 and 2, right? So we dump it in, so we're gonna have 1 and 1, right? We dump 1 in, so we can do 1, and then we can fill it up. So that will be 1 and 2, right? Boom, that's 3. And if it's still no good, 1 and 2, we can dump 1 again. Then we're gonna get 2 and 1, right? What 2 and 1? That's gonna go back to, so 1 and 2. Yeah, 1 and 2 is filled it up. And then, because 1 is full, right? So we're gonna have to dump 1. So if we dump 1, we go back to, hold on. So dump 1 will go back to 0 and 2. So we go back to the start. Oh, I missed the 1, 0 step. Yeah, we're gonna have 1, 0 step. Okay, so basically means what we have is the big buckets just keep shrinking, right? Big buckets keep shrinking, and then the small buckets just keep growing. Okay, it's not just. I want to find a more systemic way. Let's go back to the first example. All right, so I'm going to start with 0 and 5. Right, and then we dump 3 in, so we have 3 and 2. Right, and then we can dump 2 in, then we get 2 and 0. Right, we get 2 and 0. And we can, so this is from the large to small. And when this is done, we can actually do 2 and 5. And we fill in the big one again, 2 and 5. And then we dump again. Now we're going to dump inside, and we're going to have 3 and 4. Right? And we can dump again. It'll be 3 and 1. Right? And we can dump again, which give us 1 and 0. Right? And then we fill up again. That becomes 1 and 5. We dump again, 3 and 3. Right? Dump again, get 3 and 0. Right? And then we get 3 and 5. Then we get 3 and 5. So when is the time that we stop? So we get to 3 and 5. So the next round, we're always done from large to small. So that's going to be 3 and 2. Boom, that's when we stop, because we go back to the same. Okay? Now if we take a look, that's 520, 5410, 530. Okay? So for the other thing, 0, 6, so we dump 2, so get 2 and 4, dump 2, 2 and 2, dump 2, 2 and 0, nothing can dump, and then 2 and 6, right? And then dump 2, so get 2 and 4, boom, we'll repeat. Okay? The last one, we have 1 and 2, so we have 0, 2 to start, then 1 and 1, then 1 and 0, then 1 and 2, then 1 and 1. Boom. So we actually don't have to go. We can just, it will repeat itself once the large one go back to, once the large one and the small one are equal to the capacity. I'd rather just check. I think that would be easier. I'd rather just check if it's any repeat. And this can obtain all possible things. Okay? I think so. Want to try? Yes, I do. Let's try this. What do you think gonna be the... I don't know, what's the runtime? Well, if you think about it, I actually don't know what the runtime is going to be. The larger one divided by the smaller one. It's not going to be larger one divided by the smaller one. Come on. It's going to be 365. The large one mod smaller one. How about that? Large one mod smaller one times large one divided by smaller one. That would be my guess. And all we need to do is just follow through. We just get all possibilities and then check along the way. All right, let's see if our idea works. Hold up. I need to do something important. All right, back at it. All right, so the idea is we're gonna have a set. So scene equal to a set, and I need a big and small. All right, so I'm gonna say J1, Jug1, Jug2 is equal to Jug1 the minimum of Jug1, Jug2. J2 is going to be the maximum of Jug1 and then Jug2. Okay, so we have J1, J2. Now we're going to go through what are we going to go through? So we're going to go through a while true, right? So the first possibility is going to be P1, P2, possibly 1, P2. Maybe we should set up P1, P2 on the outside. And then we always fill up, right? Hold on. I always move the big one to the small one and do a check, right? And then we fill up the big one and do another check. And then big one to small one. Depends. If the small one is full, then yeah, so always big one to small one. So big one to small one, we can check, and then fill up big one. How about we fill up the big one first? Okay, we fill up the big one, then we do a check. Big one to small one, we do a check. And then next round coming up. Next round coming up. The big one to small. Oh, it depends. If the big one has a value, we just go to small. Otherwise, okay, so how about this? P1 and P2 both are 0 start, right? So I'm going to start with this. Let's say while P1 and P2 is not in, right? Is not in scene, okay? Is not in scene, right? So P1, P2 comes out. When do we check? We check after we make the move. So we say if P2 is larger than 0, all right, if P2 is larger than 0, then we put P2 into P1, all of P2 into P1. How do we do that? Now we're going to say the amount we can move, right? So P1, depending on how much P1 has, all right? And also if P1 is smaller than J1, it depends, right? If P1 is smaller than J1, then we just add the difference. If P1 is equal to J1, then we always add the full J1. Okay, so I just want, like after movement, what is the final result, right? And also if P2, so P2, so that's blah blah blah, right? If P2 is equal to 0, then we have something, okay? And then after this, we always check and then push it into the, oh, wow, true. Anytime we see it, then we're gonna, okay, so that's first round is a check, okay? Now after the first round, so we move to this, then what? Then go back. Oh yeah, that's it. There are only these two positions, right? Okay, so if P2 is larger than 0, then we're gonna move whatever is inside P2 to P1. So we're gonna say the amount of movable, right? Movable shall equal to J1 minus P1, all right? J1 minus P1, and of course, if P1, J1 minus P1, it depends if P1 is smaller than J1, right? If P1 is smaller than J1, now we do J1 minus P1. Else, or the only else possibility is J1 equal, P1 equal to J1. If P1 equal to J1, then basically what we're saying is, again, the question of when do we check? going to fill, right? Now I'm going to check. Fill, then we check. Okay. So if P1 is equal to J1, right? P1 is equal to J1. That means we have to dump the entire thing, so that's going to be P1. No, that's going to be J1. If P1 is equal to J1. P1 equal to J1, that means J1 is already, P1 is already full, right? So if I want to dump, we have to dump the entire J1. So that's the movable. So it's actually not a movable, the maximum movable, right? This is the maximum movable is this. Okay, so when I got a maximum movable, then we try to move, right? We try to move. How much can we move? It depends on what P2 is, right? And the maximum movable, actual moved, or equal to max movable if P2 is larger or equal to max movable, right? Else, if P2 is smaller than that, it's going to be P2, the actual movable, actual moved, right? And then we're going to move, right? I'm going to move. How do we do the move? When I say P1 will equal to P1 plus actually moved, right? And mod J1. Think about it, right? Actual moved. Well, it's actually not right. It's actual moved. Because the actual moved, that can be 0. Let me think again. Maximum movable is the capacity minus currently it's in it. So we have this much, right? So P1 plus, and the actual moved will definitely be smaller than the maximum movable. So P1 plus this will always be good, right? So the only situation that's bad is if P1 is equal to J1, right? If P1 is equal to J1, then shouldn't that be its own situation if P1 is equal to J1? If P1 is equal to J1, then the new P1 will either equal to J1 or equal to the remaining of this. Okay? So that's reasonable, right? That's reasonable. If P1 is smaller than J1, then we're going to add whatever is left. Okay, I'm going to change this. If P1 is equal to J1, all right, then moved, we can direct how moved will equal to P1, right? Or we can actually just say P1 and P2 is going to equal to, so P1 is going to be either J1 if P2 is larger or equal to J1, right? If P2 is larger or equal to the capacity of J1, and everything can go there. Else, right? Else, what's the else? P2 is smaller than J1, and then that's going to be P2, all right? And then for P2, same thing. If P2 is larger or equal to J1, that's going to be P2 minus J1. If P2 is larger or equal to J1, else if P2 is smaller than J1, then that's actually going to be 0. So what we can do is say this is going to be this, right? If this, else, that's going to be P2 and 0. Okay, so that's P1 equal to J1. Else, then P1 is smaller than J1, right? If P1 is smaller than J1, then we have the max movable, right? The max movable will equal to J1 minus P1, exactly. And then P1, P2 is going to equal to something if, I'm going to call it MM, max movable, right? So this is a max movable to J1, right? So we say if P2 is larger or equal to MM, right? So P2 is larger or equal to MM, so we can move MM into P1, which make P1 into J1, and P2 into P2, just minus MM. Else, if P2 is smaller than MM, right, then we're going to move the entire thing, and this is going to be P1 plus P2. Okay, so that is the first situation, right? If this is larger than, then we blah blah we obtain the new state. Okay, and then if P2 is 0, right? If P2 is 0, now if P2 is 0, then the only thing we can do is to add something to P2, right? Add something to P2. So we pull something to P2. Then we say P1, P2 will equal to, P1 actually didn't change, so we can just say P2 is equal to J2. It's the only option we can go. Once we're done, we get P1, P2, then we're going to check, right? We're going to say if P1 is equal to target, or P2 equal to target, or P1 plus P2 is equal to target, which we can simplify to say if target is in P1, P2, and P1 plus P2, then we return true. Right? If not, then we say scene dot add. Oh. Well, if we, in this case, we can actually just say here, right? We just go P1, P2, not in, well, not this one, in scene, then scene dot add P1, P2. I want to break out, I want to return false. And once we find the circle, start back, then we're gonna just quit. All right, we have not many test cases. So we have 3, 5, 4. That's going to return true. What's the other one? 2, 6, 5. 2, 6, 5. Return false. And then 1, 2, 3 return true. And we can also run a quick check. We can say if target capacity is larger than J1 plus J2, then I'm going to return false. Edge case. If the largest is J1 plus J2. Okay? So we have, we're going to put J1, J2, target. And here we can say sol dot can measure J1, J2 target. Right? Run this. Target is not defined. Where? Oh, target capacity. Okay, pass. So we can run a little check. You want to run some test cases? Okay, we can run some test cases. Some random stuff. And I don't know. I pressed. Alright, so what? Like this. Like this. Like this. It's probably false. Just very random numbers I pulled. Oh, it's true. Oh, how do you know? It's true. All right, let's try then. Test 1, I'm going to try. Okay, so let's see. Yeah. Let's give it a shot. Submit. If it's wrong, then it's wrong. We try to figure out. It is not wrong. It is not wrong. So, okay, we got this one. All right. I don't even know how to describe this. So, my idea is to always pour water from the big jug to the small jug. Right? From the big jug to the small jug. Record the state of after each pour and see if the target capacity can be reached at any state. I cannot prove it, but I know, like from empirically, I know that no, we know. This process will definitely circle back to the original state, right? And that's when we quit the check. So the runtime, honestly don't know the runtime. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? 5 to 3 is 2. So we can go 2, 1, 0. 2, 1, 0, that's 3. And for each one, you pull it 2 times. 1, 2, 3, 1, 2, 3, 1, 2, 3. So hold on. So 5, 2, 0. 5, 4, 1, 0. And 5, 3, 0. I'm gonna just call it O. I'm not sure. M divided by N times M mod N. It's not like completely accurate, but I feel like this fits the mood based on how I see this. And what if this mod is 0, like the 2 and 6 case? Oh, in that case, it's just going to be. How can I say? Oh, we always say +1, right? We always say this one +1, which is true after +1. But if we're gonna +1, actually the previous one we need a +1 as well, because if we divide, yeah, let's go both +1. And this one runs in 5, 12, 44. All right, I don't like my explanation. I don't like the way I do it. So let's see the smart people. Come on, smart people. Okay, this is the current state of the jug. Current state of how much water, right? How much water each jug holds. I have a math solution. GCD. Okay. Oh, it's a Microsoft thing. Ah. All right, let's see. We need a knowledge of number theory to cover the proof. Yeah, do you have proof of this? Well, I don't have like a full proof of this, but what I do know is this process will definitely circle back. That's what I know, right? Because each time I pull water from the large jug into the small jug, right? And then this process will eventually end up with a large jug the 0, right? No matter what, a large will become 0. And then a large will fill up, and I will keep pouring. And a small one, right, will definitely at a certain point, the small one will also fill up, because each time the larger one pouring the small one will fill up. So it's guaranteed that we'll reach a point where we'll circle back to the start. Now the only proof is whether this process can capture all different types of combinations. Now that I do not know. But this is a GCD. Microsoft uses this. No, of course they don't know. They just randomly pick some questions, I guess. And it is an interesting question. To use the property of, I can't pronounce this, Bézout, Bézout identity, and check if Z is a multiple. Of GCD X and Y. Let A, B be non-zero integers, and let D be their GCD, then there exists integers X and Y such that AX plus BY equals D. x and y, ax plus by equals d. In addition, the greatest common divisor is the smallest positive number that can be written as ax plus by. Every integer of the form is a multiple of the greatest. That's true. But if a and b is negative, this means we are emptying the jug of x and y gallons respectively. We're filling. Okay. GCD is 2. 8 is a multiple of 2. So this implies it's a valid that we can have. In this case, there is a solution obtained by filling this twice and emptying the 4 gallon just once. So filling up 6, pouring into this, we're emptying once. We got 2 left. And then we're pouring into 4, that's 2. We're filling up, oh, that's true. Yes. Special case. Oh. Wow, 2016, that's an old question. Good question. Oh, we empty it 3 times. Well, this just means like you will always fill it by this amount of times. We're emptying by the other number of times. So every time we fill, we push in this and we empty. And we fill again, and push in this and we empty. Because actually we have remaining, right? So the remaining will go in, and we add again, we push again, then we empty, and we add again, right? And push in, then we empty. And the remainder. Yeah, I do think this does guarantee. Okay. That's interesting. See the breakfast search. State. Yeah, I do think it's just it's the same. I get all the states. No need to say things like this. That's fine. Z is a linear combination of x and y. And the linear combination also allows coefficient to be negative. Choice of empty, which is a negative. So in positive case, we're carrying a constant to the cycle. G, the GCD of x and y, then Z equals what the heck is that a K? KAGN LBG. What's A and B? What's A and B? Oh, AG is x, BG is y. Therefore, Z will equal to Ka, so Z must be a multiple of G. Must be equal greater than Z, otherwise you fill up both. But still, yeah, that's true. I like this explanation. Alright, let's do this again. Okay, so this is the GCD idea. This is the GCD solution. Reference. Oops. Just trying to copy this.